Welcome to this video on the rules of exponents. Exponents, also known as powers, are a way to represent repeated multiplication. For example, 2 raised to the third power, written as 2 to the power of 3, means 2 multiplied by itself 3 times, which equals 8. In this video, we'll cover the 7 fundamental rules for working with exponents. Understanding these rules will help you simplify expressions, solve equations, and work with more advanced mathematical concepts. Let's start with the first rule, the product of powers with the same base. When multiplying 2 powers with the same base, we add the exponents. For example, 2 to the power of 3 times 2 to the power of 2 equals 2 to the power of 5, which is 32. Let's see why this rule makes sense. 2 to the power of 3 means 2 multiplied by itself 3 times. 2 to the power of 2 means 2 multiplied by itself twice. When we multiply these expressions together, we get 5 factors of 2, which is 2 to the power of 5. The second rule deals with division of powers with the same base. When dividing 2 powers with the same base, we subtract the exponents. For example, 5 to the power of 4 divided by 5 to the power of 2 equals 5 to the power of 2, which is 25. Let's see why this works. 5 to the power of 4 means 5 multiplied by itself 4 times. When we divide by 5 squared, we're removing 2 factors of 5, leaving us with 5 squared. Our third rule is about raising a power to another power. When we have a base raised to an exponent, and then that whole expression is raised to another exponent, we multiply the exponents. For example, the quantity 3 squared, raised to the third power, equals 3 to the power of 6, which is 729. Let's see why. 3 squared is 9. When we raise 9 to the third power, we get 9 times 9 times 9, which is 729. Alternatively, we can think of this as 3 squared 3 times. This gives us 3 to the power of 6, which is also 729. The fourth rule shows us how to handle exponents when applied to a product. When raising a product to a power, we can raise each factor to that power and then multiply. For example, the quantity 2 times 3 raised to the second power equals 2 squared times 3 squared, which is 4 times 9, or 36. Let's verify this. 2 times 3 is 6. 6 squared is 36. Alternatively, 2 squared is 4, and 3 squared is 9. 4 times 9 is 36, confirming our rule. The fifth rule is similar to the fourth, but applies to division. When raising a quotient to a power, we can raise both the numerator and denominator to that power. For example, the fraction 2 over 3 raised to the second power equals 2 squared over 3 squared, which is 4 over 9. Let's check this. 2 over 3 is approximately 0.66. When squared, we get approximately 0.44. 4 divided by 9 is also approximately 0.44, confirming our rule. The sixth rule deals with the zero exponent. Any non-zero number raised to the power of 0 equals 1. For example, 7 to the power of 0 equals 1. This might seem strange at first, but it follows logically from our previous rules. Consider 7 to the power of 3 divided by 7 to the power of 3. Using our division rule, this equals 7 to the power of 0. But 7 cubed divided by 7 cubed is obviously 1. Therefore, 7 to the power of 0 must equal 1. Our final rule deals with negative exponents. A negative exponent means we take the reciprocal of the base raised to the positive exponent. For example, 5 to the power of negative 2 equals 1 over 5 squared, which is 1 over 25. This rule also follows logically from our division rule. If we divide 5 to the power of 0 by 5 squared, we get 5 to the power of negative 2. But 5 to the power of 0 is 1, so 1 divided by 25 is indeed 5 to the power of negative 2. Before we finish, let's look at some common mistakes when working with exponents. First, be careful not to confuse the product of powers with the power of a product. For example, 2 to the power of 3 times 3 to the power of 2 is not equal to 2 times 3, all raised to the power of 3 times 2. Second, remember that the zero exponent rule and negative exponent rule only apply when the base is non-zero. 0 to the power of 0 and 0 to a negative power are undefined. Let's practice applying these rules with a few examples. First, let's simplify the expression 4 squared times 4 cubed. Using Rule 1, we add the exponents, 4 to the power of 2 plus 3, which equals 4 to the power of 5, or 1024. Next, let's simplify the fraction 2 cubed over 2 to the power of negative 2. Using Rule 2 and Rule 7, we have 2 to the power of 3 minus negative 2, which is 2 to the power of 5, or 32. Finally, let's simplify the expression 3 to the power of negative 1, all squared. Using Rule 3 and Rule 7, we have 3 to the power of negative 1 times 2, which is 3 to the power of negative 2, or 1 over 9. To summarize, we've learned the 7 fundamental rules of exponents. The product rule: add exponents when multiplying powers with the same base. The quotient rule: subtract exponents when dividing powers with the same base. The power of a power rule: multiply exponents when raising a power to another power. The power of a product rule: distribute the exponent to each factor. The power of a quotient rule: distribute the exponent to both numerator and denominator. The zero exponent rule: any non-zero number raised to the power of 0 equals 1. The negative exponent rule: negative exponents mean taking reciprocals. Understanding these rules will help you simplify complex expressions and solve equations more efficiently. Thank you for watching, and keep practicing these rules to become more comfortable with exponents.